Why does an application work perfectly on a developer's machine but fail in production? By the end of this video, you'll understand exactly why it happens, how Docker solves it, and why companies like Amazon, Netflix, and Google rely on this approach every single day.
Consider a scenario, we have a developer. So what's the role of developer here? They create the source code, build, and as part of build, they create the artifacts. It can be anything like mywebapp.war file. So once the artifact is created, what is the next step? Deploy to target environment. It can be your QA environment, for example. So now the artifacts, whatever you created in your build environment, it will be copied to QA environment. Let's say all these things are happening in your lower environment. Thus, this is your QA environment. So in this QA environment, this artifacts will be deployed. It is copied and it gets executed. And once the QA testing is completed, the same artifacts can be deployed to your UAT and even to your production. Now the point is, as a developer, I have prepared these artifacts, and before I promote the code to QA environment, I'll be doing a thorough testing here. I'll be doing all sort of unit level testing using a JUnit testing tool or TestNG. I can able to perform some sort of testing here. And to test my web application, what I need a web application server. Assume that I use something called Tomcat here. Using Tomcat web application server, I run this application and I'll do all sort of unit level testing. And once the testing is completed, once all the test cases are completed, then only I can deploy this to QA environment. So to run this application in my lower environment, I need this web application server. Assume that in this lower environment, I use JDK 17 and I use Tomcat 8.5, for example, to run this web application, and the application execution also is very much successful. We are good with the result. Now the same artifacts, when it enters to the QA environment, the QA testing team has to run this application, right? So for that also they need this Tomcat web application server to be configured here, correct? So now the point is, assume that in your QA or a higher environment, instead of JDK 17, they have just JDK 11. Instead of Tomcat 8.5, assume that they have Tomcat 10 version. And this war file has been deployed to this particular environment, and they want to run this war file based upon this version. Will it get executed or not? We can't say no directly. We can't say yes also. There might be some compatibility issue. We can't always say no because there might be some dependencies. There might be some compatibility issues. Assume that the artifacts, whatever they've created, it is based upon the JDK 17 and they want to run it in JDK 11, means it might not be successful. It is not the issue with the application artifacts. It is the issue with the infrastructure. That infrastructure is not enabled with the required tools. So now it is not the problem with the testing team or with the development team. It is at the deployment level. The target environment should be configured accordingly. Same situation occurs in the UAT as well as in the production as well. The applications, whatever successfully in the lower environment, it might not be successfully started in the higher environment because of the compatibility issue. So to overcome this, what we can do, we can't expect the infra team to install the same set of tools in all the target servers. If you're working on your traditional monolith application architecture, it's fine because you'll be running one application as a whole. So before you deploy anything, you ensure that the tools are installed and configured in all the target servers. But in microservice application architecture, the entire application is divided into various microservices. There will be thousands of microservices for an application, and each and every microservice will be having its own tool stack. One can be with JDK 17, one can be JDK 11, one can be with Oracle JDK, or one can be with Open JDK. A lot of differences, a lot of version level differences and compatibility will be there. So practically it is not possible to install all versions of JDK and all versions of Tomcat in your target server. So to overcome this, what we do means we take an approach called containerization. So here on development or deployment perspective, we can use a concept called containerization. Containerization means the process of packaging application along with the dependencies. So now the application is this one. So what I'm going to do here is, before I deploy to target environment, I'm going to package this application along with the dependencies. So what are dependencies for this application now? This JDK 17 and Tomcat 8.5 is a dependency. Package it and give a valid name of the package, image v1.0, something like this. So the war file, whatever we created, it is an application artifact. I just want to create an image out of it. So this image is just a static file. The package, what we call here on container or Docker perspective, we call it as an image. It's an application image. There is a difference. Okay, this I consider as an application image and this I consider as an application artifact. Got it? So using this application artifact, we are going to sum up all the dependencies and create one image out of it. Once this image is created, we are going to deploy that image directly to target environment. Image to target environment through container registries. Now, instead of deploying the war file, when the image enters into the target environment, this image is already having the dependencies along with it. So it means even in the target environment, whether you have JDK installed or not, whether you have Tomcat installed or not, that is secondary. Using this image, I'm going to create one container and I can able to run that application image in the container directly. Similarly, in all my target environment, I'll be able to deploy this and run run that application as a container. So with this, you no need to worry about the infrastructure. Okay, whether your infrastructure is enabled with the proper required tools or not, that is secondary. We are just packaging it and deploying the application images, and it can be executed in any target environment. With this, you no need to rely on your tools compatibility and other stuff. So let's understand what are the basic terminologies we have here. So the very first thing which I used here is container engine, container image, and also we use one term like container itself. We use a term container registry, and also we have some terms like container repository. So these are some terminologies you need to be very clear before you actually start creating this. So ultimately, container engine, right, it is used to create and manage the container images and containers. If you want to use Docker, means you need to use Docker container engine. So we'll be installing Docker container engine. In order to work or in order to create any container, we use a term called container image. Container image is just a static file that defines the properties and dependencies of the container or application, I can say. The container images are non-executable. It's composed of various layers, and these layers are created using the instructions like Docker. If you're using Docker engine, means we can use the Docker file instructions. So just keep in mind, it is just a static file and it is non-executable. It is just to define the properties and the dependencies of the application. For example, consider this is my application, and when I create an image, this image is going to have the properties of the application along with the dependencies, and directly you cannot run the image. That's why it is called as a non-executable entity. And each and every incremental change that you make in this particular image, we call it as a layer, and to build that layer we use some instructions. Now the next important thing is about the containers. So these containers are the executable units of container image. Simple as that. If you want to execute any image, that image will be executed as a container, correct? So you will be passing an input as container image, and based upon that you will be running a container. So this process of creating and managing containers is what done by your container engine. Another important thing is the container registry. So these container registries are nothing but, you can consider like a repository. Okay, it is basically used to manage version control the container images. Simple as that. What is the purpose of GitHub? So whenever developer creates any new version of the source code, it can be version controlled in your GitHub repositories. Similarly, whenever you create any version of your application image or a container image, these versioning can be maintained in your container registry. We use one container registry called Docker Hub. We are going to use Docker Hub as a container registry to manage our images. Another important thing is your container repositories. So these container repositories can be considered as a subset of container registry. Simple as that. So it means within your container registry, you can have a number of repositories can be created. Like say, for example, you have created a GitHub account. Once you create a GitHub account, within that account, you can create a number of repositories, right? Source code repositories. Like this, within your container registry, you can able to create any number of container repositories. It is a subset of the container registry. Clear?